some of our greatest innovations came to us simply by copying nature. Think about it, all the way from Archimedes to Da Vinci, all the way up to modern engineers. We look at nature and we look at what really is efficient and effective in nature, and we simply copy it and put it on our modern devices, our modern objects. This is called biomimicry, mimicking or copying nature, the biosphere. So think about it. Nature evolves to its most efficient form. So whales have flukes that allow them to move with economy of effort. That's why the rudders on submarines look like whale flukes. And peregrine falcons have wings that are kind of curved in an interesting way so that they can fly faster than their prey, which explains a lot of why aircraft or fighter aircraft are their wings are designed that way because they're really copying nature. So what we're going to do is we're going to take something that we think should be redesigned, something that's really not designed all that well, and we're going to take it apart in two ways. We're going to look at its attributes, meaning what we notice about it perceptually, seeing or hearing or smelling, its shape, its color, its size, its hardness, and its functions. Why is it that shape? Why is it that color? Why is it that hardness, right? So we're going to look at its attributes and functions of an object. We're going to take it apart. Then we're going to take apart the same thing of something we find in nature. Maybe it's an animal. Maybe it's a rock formation. Maybe it's a plant. We're going to deconstruct it by looking at its attributes and looking at its functions. And then what we're going to do is we're going to take some of the attributes and functions we find in nature. We're going to see if we can apply them to what that particular object that we're redesigning is. So let's do something really fun. Let's say we're going to try and redesign something as simple as a toothbrush. That design has been around for 100 years. It's got bristles. It's straight. It's not very imaginative. It's so that you can do the up and down motion on your teeth. And let's compare that to something like a shark. So when we take the toothbrush apart and we deconstruct it, it has bristles that are hard, that are straight. It has a handle that is straight. And the reason that we think they have that is the function is that that's an optimal way to get the debris off of your teeth. But we also look at a shark, and a shark is streamlined. It's got fins on top and fins on the bottom and fins in back. It's got a lot of teeth. It looks like a torpedo. Its skin is really smooth going one way and extremely coarse going the other way. And we take those attributes apart and we look at its function. Why is it like that? And one of the things maybe we come up with is we say, shark skin is interesting because it's really smooth in one direction, so we've got a real efficiency and economy of effort. But the other way, it's really coarse. So maybe if we made the bristles of a toothbrush more like shark skin, going one direction it would be easy, but going the other direction it would capture more of the stuff that's on our teeth. And then we'd have to figure out how to do it in such a way that it didn't hurt us and it was actually something that we could manufacture. But by taking what we're seeing in nature and applying it to the redesign of something by looking at the attributes and the functions, by deconstructing that, what we're going to do is we're going to reconstruct that object. We're going to redesign that object to be more efficient and effective. So one of the easiest ways to apply a creative mindset is to pay careful attention to things that are around you that could be redesigned, and to pay attention to where in nature those things are more efficient and effective, and apply them in the redesign of that object.